When we are talking about properties of logarithms, the first couple rules we're going to talk about we use anyway, whether you kind of realize it or not. So the first one that we're going to talk about is called the inverse rule. So that's your first blank, the inverse rule. Okay, so the inverse rule states that if you have a log with a base a, and you're taking it times a, or you're taking it of a to the x power, you can see here that the base, these two things are the same. You guys see that? It's like log base a of a. Those are the same thing. So when those are the same thing, they cancel each other out, and you're just left with x. So when you have your base down here, that's base A, and then you have this A, they are the same thing. They cancel each other out, they undo each other, and you're just left with that x right there. That's why it says it equals x. Okay? So then, same rule, if you have a base and you raise it to an exponent that's the same, do you guys see we have A raised to log A, do you guys see that? If it's a raised to log a, they cancel each other out. They're inverses of each other. And you're just left with x. So, real life example of that. Let's skip to number 2 first, and we'll come back to number 1. Number 2 says log 7 of 7 raised to the 2x minus 1. So do you see that log 7 and 7 are the same? So if they're the same, they're going to cancel each other out. And we just have 2x minus 1 left. Yep. I mean, this one wouldn't be solved. We're not finished. We're just showing you an example of what happens. Typically, there would be something over on the other side of the equal sign, but just for this example. Now, number 1 is something that we haven't talked about yet. We have this thing, and if you look on your calculator, you'll see it says ln. I believe it is underneath the log button. You guys see ln? Ln really means natural log. That's what ln means. It's natural log. It's another function of a logarithm, but for the sake of what we're doing in this term, we're not going to go any further and talk maybe what it means. Just know that it's another type of logarithm, if you will. And then we have this letter E. All right, so we have a letter E that we use as a constant. In your calculator, if you notice, just waiting on you. On your calculator, if you hit second ln, it pops up an E on your calculator, right? And let's do E to the first power. So it automatically pops up an exponent. Put 1 in there. What do you get? 2.71 blah, 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 right? Yeah. That means this letter E is always the number 2.71. Can you think of anything else in math that we use as a variable, but it represents a specific number every single time? What? Pi, right? Pi represents 3.14 no matter what. The same thing is true about this letter E. E represents the number 2.71 no matter what, okay? But E and natural log are inverse operations, and they undo each other. So if you look at number 1, example 1, it says e to the ln x squared. And I just said that e and ln are inverses of each other. So it knocks it out. And you're just left with x squared. So that's what inverse rules are. They knock each other out, for lack of better terms, not math terms. Okay. And then you're just left with whatever is remaining in the exponent. Okay? So that is our inverse rule. The next rule we're going to talk about is called the logarithm of a product. So that's your next blank there, is logarithm of a product. The logarithm of a product, or the product rule, states that any multiplication logarithm problem with like bases condenses into an addition problem and vice versa. So what you need to remember about the product rule is multiplication turns into addition and vice versa. Multiplication turns into addition, addition turns into multiplication. If you think of the word condense, what do you think of? To shrink, to make smaller. So example 3 says, condense each logarithm into a single logarithm. That means you're only going to write the word log one time. So if you look at example 3, would you agree that they both have log base 3 in common? Okay, so essentially we are, if you want to think about it like this, we are factoring out that log 3. And what are we left with? X and 6. And we just said addition turns into what? Multiplication. So this turns into x times 6. Please don't use a times x symbol. Use a dot for your times symbol. We put parentheses around the x and the 6 because that's the two things they're getting multiplied by. And if you think about this, if we, quote, distribute this log 3, that gets back up to here, right? If you, quote, are going to think about it as distributing. How else can we write x times 6? What do we usually write instead of that? 6x. So we could really write this as log base 3 of 6x. And I shouldn't hear any calculators because we don't need them right now. On number 4, seems like a lot, but what do we have in common among all of them?
Log A.
Log A. So I'm going to pull log A out. And then what do I have left? C times A times B times I.
Log cabin.
There it is. A log cabin. Good.
Wow. That's awesome.
Okay, and so all we're doing really is we are just multiplying together these bases right here, the A, the B, the I. So it doesn't matter whether they're giving you numbers or variables, we just put them together. Okay? Now, on number 5, what's the word there? What does the word say to do? Not condense, it says expand. And to expand something means to, not blow it up, make it bigger, right? To expand something means to make it bigger. And so, again, we know that multiplication turns into what?
Addition.
Addition. Maybe we should write that up here. Addition turns to multiplication. So I have this multiplication problem, natural log of x times z. But instead of multiplication, I'm going to turn this into an addition problem. So we know that the natural log of x, am I just going to write plus z, do you think?
Ln Z.
Okay, look at what happened up on example 3. Do you see that the log goes with both of them? So down here on example 5, the log needs to go with both of them as well, or the natural log in this case. So we have the natural log of x plus the natural log of z.
How come you have a cursive L on the bottom, not for log?
What?
You have for L.
Because if I just write ln, that looks like 1 in, right?
Okay. I was curious.
So it doesn't have to be cursive, but for most of you writing this, ln looks like 1 in to you because you're not used to seeing ln, which is why I use a cursive L. Okay, example 6. Why don't you see what you can come up with for example 6? Think about our rules. Who wants to offer their answer? Josh?
Log 5 times 3 plus
Okay, so we would say log base 5 of 3. All right? Then what?
Plus log base 5 of 2.
Okay.
Log base 5 of 9.
Excellent. Does anyone else have this answer? Raise your hand if you have this answer. Okay. Remember that all I'm doing basically is distributing these, the log 5 to each of these, and we know that multiplication turns into addition. That's why I use an addition sign. Patrick, do you have a question or you're stretching?
Stretching.
Okay. My 3 right here kind of looks like an exponent, but it's not. It should be regular size of the logs. The 5 should be little. The 3, 2, and 9 should not look like exponents. Okay? Questions on this product rule? Okay, so if we talk about multiplication and addition, what have we left out?
Subtraction and division.
Division and subtraction. So, number 3 is the logarithm of a quotient. Quotient means the answer to a division problem. So we are going to say that division turns into subtraction and vice versa. Division turns into subtraction, subtraction turns into division. So number 7 says to condense each logarithm. Condense each logarithm, which means we're going to make it smaller. So on number 7, they both have what? Log 3. So that's essentially what we're going to pull out. And subtraction turns into what? Division. So this is a subtraction problem, so I'm going to turn it into a division problem, which is a fraction. 24 comes first, so it's going to go on top, over 4. It does reduce, but I want you to leave it as 24 over 4, because if you have to go back into the other form and expansion, and you only have log 3 of 6, how are you supposed to get back to this, right? Was that 30 divided by 5 to make 6? Was that 60 divided by 6 or 10 to make 6? So I'd like you to just leave it as this. Okay? Now, number 8. Why don't you see what you can do on number 8? It's natural log, but it means the same thing as log in this instance, in this example that we're doing. Who would like to offer their answer? Anthony, thank you. What did you say?
Well, I got kind of like 2 answers because I didn't know what they did.
Okay, pick one of them.
But the first one I got like L and X to the 3rd.
Okay, because you went ahead and divided.
Yeah.
But before you divided, you have x to the 6th over what?
Over X to the 2nd.
This is how I would like you to leave this problem. Okay? And if you were to divide it anyway, it would be x to the 4th, right? Because you subtract your exponents if you actually were going to divide it. Okay, so I want you to leave it as this, ln x to the 6th over x to the squared. Okay, what about number 9? So now it says to expand. So now we're going the opposite direction. So we're going to take a division problem and make it what? Subtraction, okay? Who would like to try number 9? Crystal?
Take the log to the base of second out, put 32 in parentheses, minus log to the second, parentheses 4.
Okay, you don't need the parentheses still in there. Okay, and I would say log base 32, I'm sorry, log base 2 of 32 minus log base 2 of 4. Good. Okay, try number 10. Kyle, would you like to give us your answer?
Sure. How do you say it? Like
Natural log. Yeah, you would say natural log.
Natural log of y squared minus natural log of 3.
Perfect. Natural log of y squared minus natural log of 3.
So would it be wrong if you put them natural log of 3 first?
Yes. Because is 4 minus 3 the same as 3 minus 4? Is that the same thing? No. So it's not going to be the same thing. Subtraction is not commutative, which is that word that we're looking for. Okay. Any questions on these two? Expanding and condensing? All right, let's look at another rule here. The logarithm of a power. The logarithm of a power. The power rule states that the logarithm of a power of a number is equal to the power times the logarithm of the number. What? Exactly, right? What does that mean? Okay, so let's make it easy. All this is saying is if you have a log base 2 of x to the third. Okay, let's write that example down. Log base 2 of x to the third. The power rule states that this power comes out to be a coefficient. So then this would become 3 log base 2 of x. So all it's saying is that an exponent becomes a coefficient out front. If we were to go, this would be expanding it. So if we were to condense it, this 3 would become an exponent here, right? That's if we were going back this way. Okay, so they swap places with each other. Okay, so on number 11, it says log, if there is no base here, this is important, if there is no base here, it's always base 10. It's always base 10 because your calculator is always base 10. Okay, so if there's no base there, it's going to be base 10. You don't have to write it there if you don't want to, but we might need it in the future as we go through some of these problems. So if I want to rewrite this using the power rule, if I wanted to, we would ask to expand this problem. If I'm going to expand this, that 8 is going to come out front. I should have 8 log, if you want to put the 10 there, that's fine, base 10 of 3. That would be expanded. What about number 12? There is no exponent, right? You guys see an exponent there? Okay, but in unit 4, we talked about this. How can you make a square root become an exponent? Close. Not a 2, but remember the root is 2 here. What's the exponent of the 3? 1. So remember, if I can make that 2 go down to the denominator, so this would be 3 to the 1/2 power. Do you guys remember doing that? Right? Where the 2 came out to be the root, and we would do the square root. You guys remember doing that? Please say yes. Yes. Thank you. So then I have my log here. So this is not fully expanded because we still have an exponent. So what am I supposed to do with that 1/2?
Throw it out front.
Throw it out front. The 1/2 goes out to the front. I have 1/2 times log of 3. What is the base here of the log? 10. But you don't have to write it if you know that it's 10. Any other time they give it to you, you have to write it. It's only when it's 10 that it's understood to be there.
You want us to do that on the test? Put 10?
It doesn't. I don't think I'd give you a problem like that where that's an option. But if you do see it, yes, that's fine.
All right.
Okay. Now, number 13 is a little bit tricky. Do you agree that this 3 on the outside is going to both the top and the bottom, right? So I'm not going to distribute it to top and bottom. The first thing that I'm going to do is take the 3 and move it out front. So I have 3 log of x squared over y. Now, before I can deal with that x squared, a division problem becomes what? Subtraction, right? So I'm going to take the 3 log, since it's going to both of them. I'm going to have 3 log x squared minus 3 log y. 3 log x squared minus 3 log y. Remember, I took this I took this division problem. I changed it into subtraction. Does this look fully expanded to you? Is there anything we haven't dealt with? What, Tish? The exponent, right? We still have an exponent hanging around. This is not fully expanded unless you get rid of the exponent. But the problem is, I already have a 3 there. Right? So how are we supposed to take? Excellent. We're going to multiply 2 times 3. So I have 6 log x minus 3 log y. That would give me my answer.
Mine came out looking like
Look like what?
loggy.
Loggy?
Yeah, it's like LOG.
The old loggy?
Came down.
That's right. We're doing loggies today. Okay, any question about the power rule? Okay, this box here, this gray box, is a summary of all the rules that we've already talked about. Okay? So when you say to me, I don't understand, I'm going to point you to this box and tell you to try and read the box before you ask me. So let's look, for example, at number 6. Okay, so number 6 says division becomes subtraction, right? So we know division becomes subtraction. We've already talked about that. If you look at number 7, it's the power rule that we just talked about. That exponent's going to go out front. Number 5, multiplication turns into addition, right? So all these rules we've already talked about. It's just a summary of them here. All right? So let's look on a few more examples that are a little bit more intense. It says rewrite each expression using sum and or difference of multiples of logarithms. So all that they're asking us to do on 14 through 16 is use the rules that we just learned about. Okay, so on all of these we are expanding. So let's write that word up there because in your homework it says expand or condense, and so I want to make sure you know this means that we are expanding. See what you can do on number 14. We've already kind of done one like number 14. See what you can do. What's the first thing you did, Amanda?
ln 3x squared minus ln yb.
Okay, I would agree with that. Next step, Cynthia, what'd you do?
I didn't.
You didn't? You said? Is that what you said?
Yeah, I didn't do it.
Okay, what do you think we should do next? What do you see that still needs to be broken apart?
The exponent,
Okay, the 2, what are you going to do with that 2?
pull in the front.
Okay, of just the first one, right? Only the 3x is being squared, so I don't put it on the second one. So I have 2 ln of 3x minus ln of yz. What else do we need to do here? No one sees anything else? Do you guys see that there are 2 things that are being multiplied? Y and z are being multiplied times each other, right? You guys see that? And multiplication turns into what? Addition. So this becomes ln of y plus ln of z Do we have any other multiplication up here? The 3x. Okay, now let's talk about this a little bit. If you look at the x, this 3x squared, what part is being squared? Just the x, not the 3, right? Just the x. So when we put the 2 out in front, the 2 in front really only goes with the x squared term, right? So we have to be really careful when we do this. We're going to have the ln of 3 plus 2 ln of x, of x, and then we have our subtraction there. So really, we kind of messed up between these two steps because we should have split the 3 and the x squared first, because the squared is only going with the x. Do you guys see that? Because if I put a 2 in front of this ln, that means it's 3 squared, and is the 3 being squared in the problem? Is the 3 being squared in the problem? No. So this would be my final answer right here. Okay, I think doing a couple more will be helpful. Let's look at 15. We have a lot going on in 15. The first thing I would notice is that it's a multiplication problem. Multiplication turns into what? Addition. Okay, so let's kind of split these things first into an addition problem. Do that first. So it should have log base 3 of x minus 1 squared plus log base 3 of y cubed. Anyone have questions on that first step there? Okay, Chelsea, what's one thing you think we need to do now? There's a couple things, so there's not just one answer. What's something that you see that's problematic that we need to keep working with? Okay, that 2, that's squared. Where's that squared going to go? Excellent. The squared needs to go out front here. So I have 2 times log base 3 of x minus 1. Good. What else do I need to take care of here? Quentin? What else do I need to take care of? I got the same thing over here, right? Is that what you're talking about? So that's going to go out front, plus 3 log 3 of y. Now, do we need to split this x minus 1 apart?
No.
Why not?
Because it's all grouped together and you can't do it.
All right, good. Emily's reminding us that it's all grouped together. It's already in parentheses. So if we were to change it to division, first of all, that would be incorrect. But changing it to division is condensing it. It's not expanding it, and we're trying to expand here. So, and because it's in parentheses, that means it's one big number. So we're leaving it as this. Why don't you see what you can do on number 16? See what you can do on number 16. Think about what division becomes. Okay, Justin, what's the first thing you did?
I changed division to subtraction.
Okay, so what do you have when you changed it?
Log base 10 x squared minus log base 10 pi 8.
Do we have to write log base 10, Austin?
No.
You don't have to, but it's there.
Where's the base 10 come from?
So one of the things that we talked about was that if it's not there, if there's no base there, it's always base 10. All right. What else? What comes next, Tracy? What's something you saw from there? Okay, take this 2, take it out front. Does anyone else see anything else that needs to be finished?
You gotta separate the 5 and the
Ooh, the 5 in the A is a multiplication problem, right? 5 times A. So Kyle, what did that change to?
log base 10, 5, I don't know, plus log base 10a.
Perfect. Multiplication turns into addition. And I have 2 log 10 of x. Excellent. Questions on this? Okay, let's go backwards. Or go the other direction. So 17 and 18, we are condensing. All right, so 17 and 18, we are condensing. So write that word up there where it says write it as a single logarithm. If it's a single logarithm, that means we are condensing, which means we're making it into one problem. What do they all have in common? Log. Now, before I start doing things, I need to notice that this 3 out here is in front of it. And if it's in front of it, it becomes a what? No. It becomes an exponent, right? So before I rip all the logs out, I need to make sure that I don't have an exponent there. All right, so I pull out a log from all of them. Now there are 3 things, so we're going to take them 2 at a time. So the first thing is an addition problem. So I have x minus 1 times 3. And I'm going to use brackets since I already have parentheses in there. So I changed the first 2 to be a multiplication problem. And I still have this minus log x cubed. All right, we already changed the 3 to be a cube. What does subtraction turn into? Division. So they both have just log. I have x minus 1 times 3. The whole thing is divided by x cubed. Now, whether you put your 3 behind the x minus 1 or in front of the x minus 1, I don't really care. It's the same thing. This would be finished. Okay, this would be finished. Not a lot to do there. We're just taking 2 at a time. On number 18, 1/2 becomes an exponent. But what did we say, like, y to the 1/2 really becomes what? Do you guys remember?
Y squared.
Not y squared.
Like square root.
The square root. Remember, the denominator comes out and we have the square root of y. Do you guys remember doing that? So on the first example, I can say this changes to be log y to the 1/2. What does this other one change to be? Log z to the what?
1/3.
To the 1/3. But if we go another step, I know if I raise something to the 1/2 power, it's really the square root. So I have log times the square root of y minus log times the, is it the square root of z? Ooh, the cube root of z. Remember, if it's a 3, we write the cube root of z. Last step, Hortensia, subtraction becomes what? Division. So what is your final answer going to look like, Hortensia? Is it y squared, or did we already change it? Okay, so what's going to be in parentheses? Cube root. The square root of y over the cube root of z. Now, in your homework, they're not this complicated. Okay? So I'm trying to prepare you right now so that when you get to your homework, okay, oh, this is no big deal. Okay? And the ones on your test are no big deal. Any questions on 17 or 18? You guys are quiet today. I know you're ready for the last day of notes to be over with. Last thing here is called your change of base formula. Kaylin, sit up, please. This is called change of base formula. Because we want to be able to use our calculators. But the problem is, if my calculator, or if my problem is not base 10, we can't use our calculators. Right? So if I look at this example, it's not from notes 4.2, that's something else, so you can cross that out. If you try to think about a number, 5 raised to what number is going to give you 9? Let's think about that. If I do 5 to the first power, that's just 5, right? What about 5 squared? What is 5 squared? Okay, so I'm way past number 9. So obviously it's going to be a fraction or a decimal, but how am I supposed to figure out 5 to the 1.2? What's 5.5 to the 2.9, right? Like, I'm not going to sit there and do that. That's going to take us forever to figure out what decimal value do I raise 5 by, 5 to get 9. So instead of that, we're going to do what's called the change of base formula. Okay? So we're going to change the base around, and then we're going to be able to use our calculator. The first step when we do change of base formula is to put it into log form. So if you were gone for notes, we had b to the y equals x, which is the way that number 19 is already set up. And I am changing this into log base b of x equals y. So the first thing to do is to change number 19 into log form. So the 5 is my b, the x is really the y, and the 9 is our x value. All right, I'm just labeling it. So then if I want to change it into log form, it says log. What is our base b here? What's going to be my b? 5. And my x value is 9 equals x. This part is what I'm focusing on. Because if I put log in my calculator and try to do log 5 of 9, it's going to do log 10 of 9. So now, if you look at our formula over here. Now I have created log base a of b. Do you see that? This is the same thing now. Right? I have my a down there and I have my b there. You guys agree with that? Hey, if you talk back, we're going to get done faster. Okay, so my a value is 5. My b value is 9. I change this to be log base 10 of the b value. What's my b value? 9. Log base 10. No. Look where we changed it to in that red box. We changed it into logarithm form, from exponential to logarithm form. Now, here's a way that I remember this. 5 is already low. It's already down low, right? And so if it's already down low, it's going to go on the bottom. That's how I remember that. Which one goes where? Now we can use our calculator. So let's pull up our calculator that you all have. When we get to our calculator, you need to do log of 9. Notice that your calculator doesn't have base 10, right? It just says log of 9. Divided by log of 5. What are you getting? 1.3652. It says round to 4 decimal places. So 4 decimal places would be after the 2. So after the 2, I'm sorry, what was the answer? My calculator disappeared.
1.36521.
36521, but this would be 4 decimal places. Is the 1 big enough to change? No. So what this means is if I were to take 5 to the 1.3652 power, I should get really close to 9. I want you to try that on your calculator. 5 raised to the 1.3652 power. And we should get really close to 9. What did you get? 8.999. That's pretty close, right? If we had not rounded, we would have gotten 9.
We have an error. Can't get it off.
There you go. Arrow down.
Oh, it did
You just need moral support. Okay, try number 20. See what you can do on number 20. The first thing you do is change it into log form. Identify your b, y, and x. I want you to show me the step where you're doing log base 10. Make sure to close your parenthesis. You don't have to hit a second. Just make sure that you close your parenthesis after the 5 and then hit divided by. Yep. Well, you don't need your 10 there right now, so erase the 10. And now from this step, you have this now lined up. So now from here, go to here. Okay, the x and the 5 need to be changed around. Make sure you take it to 4 decimal places. Good. Now you're at this point. Now switch it to here. Okay, you're at this point here. Now switch it to here. Write that out. You don't need a 10 here. Erase that. You now are at this point right here. So now switch it over here. 54. Is that what you got? You're using LN. Make sure you're using log, not LN. Good. That's right, Cynthia. That's right. Okay. So you're getting 54. Okay, so if you do log of 5 divided by log of 1.03, make sure that you've closed your parentheses. Yep. Look at the way that mine is on my calculator. Log of 5, close your parenthesis, divided by log of 1.03. You're getting 54.44868. So if I'm going to pause it there, after 4 decimal places, I have 54.44868. This is my stopping place, 4 decimal places, and that 8 is big enough that this needs to become a 7. Does anyone have any questions on number 20?
What is right on that? Or like this?
Okay, Kyle just asked a good question. You can leave it as just this, log base 10, 5 over log base 10, 1.03. Yeah, like this. Okay, we are going to pause. We're not going to do the story problem. That's going to be our next lesson, so we're just going to pause it there. Let's take a quick break.